Hello, dear students. Welcome to Math 223 summer sessions. I'm gonna make this recording for all my summer sessions. So if you are one of the 10-week, 7-week, or summer 1, summer 2 sessions, welcome to this class. In this recording, what I will do is to take you through the syllabus of the class, and it's gonna be very brief. So here we are, we have the syllabus. You will find that in the syllabus tab on Canvas. I will also show you around the Canvas page to show you how all these things are actually in Canvas. So let me go to my syllabus page and let's start scrolling here. The first thing I should tell you is about my email address that you can see in the syllabus, hcode@mc3.edu. So you can always email me if you have any type of questions. Math 223 is a 4-credit differential equations or an introduction to differential equations class. It's your typical second year 200 level differential equations course. So it has a set contents that you should master at the end of the semester. Yeah. So actually, I can see the first mistake into my syllabus. If I go here, look, it says we meet 4 hours a week for 15 weeks. Not in our class. In the summer classes, in this case, it's a online free, which is a summer 1 7-week or 6-week course. So that I need to increase. So it's an asynchronous class without meeting times, and you will find that I'm extremely hands-off. Right, I will kind of set it up in some way, and then most of the time you will be on your own with those materials. I will, however, record a set of lectures that you can access. Let's keep going in the syllabus. By the way, you can always book an appointment by emailing me, and I'm happy to meet in person, not just by email back and forth, but we can set up a Zoom meeting and you get your office hours. I get paid for the office hours. Here is the official course description. It says a course primarily in differential equations and related topics. Topics include differential equations first order, linear differential equations of higher orders, stuff like this. This is taken from some document called the Act 335, and I will link that into the description. But I will come back to that later. But if you look at the learning outcomes of the Act 335, you have them in here, right? Those are the official learning outcomes of the class. And one thing that I have been fighting a lot is for changing those, right? Essentially, those are solve, and use technology. So solve differential equations, right? And solving differential equations is now trivial, absolutely trivial, by computer, right? So you just need to learn some syntax in some programming language, or tell an LLM, large language model, to give you the syntax, and then you can run a differential equation solver in your computer and solve any of the differential equations that are solved in this class. So essentially, solving is no longer, enough, right? It's no longer enough whatsoever. You need to do much more than solving. However, this is the official learning outcomes. So it means that if you can do this, right, then you meet the outcomes. So in fact, this is one of the simplest classes to pass because the learning outcomes are not properly written. Almost any student can do this now. So this needs to be changed. In a sense, in my class, I will enable you very well to be able to do that using proper ways, using computers and using programming languages. But I will teach you as well the theory of differential equations, the kind of analytical, mathematical, logical structure that appends this body of knowledge, which is one of the most important math that you can learn, particularly if you are into engineering, physics, mathematical sciences. This is, a lot of our mathematical modeling is coming from our expertise in differential equations. You are in good hands. I solved differential equations for a living, mostly for about 20 years, more or less. I think it was 18 years where I have done this for a living. Not only differential equations, integral differential equations, integral equations, super complicated equations, and So yeah, I know how this is done in the real world. So one of the emphasis in my classes is to teach you how to deploy these skills in actual mathematical problems. Relevant, genuine mathematical problems. The way you would do in a job as an engineer or as a, systems expert at Lockheed Martin or whatever. This kind of job. It involves mathematical modeling. That is the key skill that you're gonna get from this class. A successful student of mine will learn all the analytical skills that you learn in any other courses, but then you will learn a bunch of other skills that actually, in my opinion, are way more valuable than these skills per se. In fact, these skills per se, you might say that they are not valuable because anybody can do this, right? You can just chuck into any chat GPT a screenshot of your differential equations problem and you will get the solution of the problem in many times correctly. So you can see as an educator, right, assessing you, evaluating your prowess in differential equations. It's extremely complicated these days. Yeah, very interesting, changes in pedagogy happening. But the topics covered are here. You can see definitions and terminology, first order equations, linear equations, non-homogeneous linear equations, systems of differential equations, and Laplace transform, as well as power series solutions. This is the typical, table of contents of any differential equations class. At the very least, you get this. Yeah, about me, yeah, I work as a physicist for many years, and part of the job is actually solving these differential equations. In fact, I consider it one of the main skills of a scientist, to be able to express a mathematical problem as a differential equations and then as a differential equation and then solve it. Yeah, it's essential. Essentially, all of Newtonian mechanics is essential differential equations, right? Force equals mass times acceleration is a differential equation. Because the acceleration is second order for the position, first order for the velocity. The Schrödinger equation, which is the equation that governs non-relativistic quantum mechanical systems, is a differential equation. There are so many different equations. Harmonic motion, harmonic oscillator, oscillations, right? Those systems are regularly modeled using differential equations. And in fact, they are so essential that I would consider them central to physics. Harmonic motion, I would say that is as important as anything else, or even more, right? It's in a way more important than the four fundamental forces, because the four fundamental forces, right, whatever they do, they will still make things oscillate, right? And they will still things end up oscillating, right? So one of the things that you will learn is how to describe oscillatory systems of different types. And that's the most important, one of the most important skills that you can get, understanding of oscillations, because everything around you oscillates. Look carefully, look out of the window, there is a tree, that tree is kind of like going in the wind. Look at those cables with electricity flowing in. If you look carefully, they're kind of like, going on a little bit. Hammer quickly, your camera, and you will see that my image oscillates. I go like this on my table, you can see, you will be able to model the shift in pixels in my image by differential equations at the end of the semester. Yes, now myself, I don't force you to buy a textbook. There are so many options that are free. Why should I make you pay $100 for a piece of junk, right? I don't. There are, however, in the hundreds of thousands of textbooks in differential equations, there might be 10 or 15 that are precious, amazing, right? The rest of them are more or less the same, right? And here you have some amazing set of notes that is available for you for free. The first item there is by an individual, Tracy, Dr. Tracy, Professor Tracy. This guy, when I was doing my research, I kind of by, by coincidence, it's actually a coincidence, right? I actually studied his work. I have, he's just a fellow physicist. I have him in very high regard, right? So I was really pleased to see that his writings, his lecture notes on differential equations, because I know that he knows what he talks about when he talks about differential equations, right? Like I know. He knows it better though, but I also know it very well. Then there are this second item. These are the lecture notes from Oxford University by Alexander Shekochikhin. Very personal type of writing style. It's not for everybody. Certainly maybe not for me, but amazing set of notes. In the end, you know, I like him. He's weird. He's a weirdo, but so am I, and I appreciate it. So, so interesting character. Check his notes. And then there are these notes. I believe that those are Paul's online notes for differential equations. And then there is the official textbook for our semester, which is by Level and Trench. And there is a website that has all the stuff. The homeworks, those computerized homeworks that you saw on Canvas, those homeworks are based on this textbook, right? So if you follow the textbook, you can, go through everything. Let's continue. So now some of this stuff has been, written for online, for face-to-face classes. So, if you are in an online class, I assume you have a computer and internet connection. Otherwise, you are not reading this. You are not looking at this. There is a notebook grade in my classes. You need to keep a diary with all your learning activities in there. I don't know, I have not very many notebooks with me here, but I can tell you, right, that I typically keep, even if it's, no, I don't have them in here. Yeah, I have kind of a pile of trash around me. You don't see this, but, I've been grading non-stop until Friday. And, jugs with coffee, Red Bull cans, you don't want to see it. Before I clear, I make a small video and I show you. But in any case, right, what I'm saying is that you need to have that notebook and you need to work on that notebook. That notebook is such an important part of your grade. I see the notebook, it's immediate to tell a notebook that is legit, not a notebook that is not legit, right? I can immediately do it. So I don't even, in most cases, don't even need to really check very much. I can just see it that you have put in the effort just by counting the number of pages and scrolling, right? But you have to have a notebook. My lectures have to be in the notebook. 3 problems for every subunit in the notebook. The cool thing and the biggest value of this class is that you learn how to compute as a scientist. So essentially, there is a bunch of scientific computing software that you're gonna be needing to succeed in my class. I suggest the Anaconda distribution for Python. That's the one I like. If you want another one, you can have it. That gives you the Jupyter notebooks. The Jupyter notebooks are very user-friendly, kind of like first way of doing it. The Jupyter notebooks are kind of similar in operation to the Wolfram language, so you kind of like get a feeling of both languages, and the entry barrier is not so high. So you need an Anaconda distribution. So there is a link there, click there, download for your machine, install your Anaconda distribution if you don't have a Python interpreter. If you never work with Python, this offers you a way in, right? Then the free basic Wolfram account. I do not use the Wolfram language for teaching, but I teach you how to use the Wolfram language to compute, right? It's a different thing, right? These are 2 different things. It's not like it's a teaching aid, right? I can do all the, it's not so much a teaching aid as it is, something I teach you, right? So yes, every time I solve a problem, you bet that I'm gonna solve it in Python and in Wolfram as well, right? And of course you will see, right, how hard work it is to solve a problem by hand, and the level of skill that goes into solving a problem by hand, and how easy it is to do this, right? The single thing that is the most value that you get from this experience is gonna be this. If you get these 2, you got your money back times 10, essentially. Get these 2. Get confident in Python and Wolfram. It's like times 10, right? I made it 10 times better for you if you get this 2. If you already have them, good for you. You get to reinforce them, to apply them for scientific computing and mathematical modeling. And then many people don't know this one, you get to know it, right? This one is a high-level programming language, even higher level than Python. Python is great because you have these libraries, NumPy, SciPy, libraries, all kinds of libraries to do all sorts of things. Then you can just like very easily call up those libraries and use the functionality built in within those libraries. So, and it's also you don't have to compile, right? So it's so nice to use. In 2000, I think it was the year 2007, I was coding in Python and I got the feeling that I was doing math by hand, right? It seemed to me that, that what I was doing, it was exactly the same as math by hand. That is how it is nice it is, Python, right? That is such a kind of intuitive language that if you are used to math by hand, when you do it, you feel that you are doing math by hand, right? Much more efficiently. And then Wolfram is an even higher level programming language. That is already everything is available to you. You just call up the function that you need, right? So particularly dissolve value and dissolve, and dissolve value and dissolve are the two functions you're gonna be using. You are welcome to use ChatGPT or large language models to do mathematical explorations or as a textbook if you want. The textbook material is there for free, right? It's public domain material that has been condensed and, so you can access it for free now. Of course, eventually, probably very soon, there will be, I don't know, I guess like commercials in the ChatGPT or something like that. But for the time being, it's pretty good. Make the most of it while you can. These things, they get, there is a period where everything is nice, right? And free, and, you can use it. Then, and I think we are reaching the end of that. So probably, within the year or so, maybe access will be somewhat more restricted or, different under different terms and conditions. I love Desmos. I think it's a great learning tool, another free tool that we can use, and Wolfram Alpha, the first artificial intelligence that people could use to do math. Wolfram Alpha is a natural language processing tool. So you say like integrate x squared dx from x equals 0 to x equals 1, and it's gonna tell you that that is 1/3, right? And it's gonna tell you immediately and accurately, and it will understand, right? When it comes to learning activities and grading, right? You have my lectures that I will be recording. This will be an example of that. The setup is not perfect yet, so I'm very dark and, it's not good. But yeah, I have to work on the setup a little bit. I didn't have the time. I didn't really want to. It's a lot more labor for me. So, this is good enough for the time being, for today. There is a set of pre-recorded lectures in Canvas. I will guide you in a second how that is, right? There are the homework problem sets. Those are computerized, but you have to solve 3 of every subunit in your notebook. There are the mathematical laboratories with videos already there that you can do. And there is a wonderful project, right? There is the project, right? So, yeah. In addition, I decided to give you a set of lectures of my own, right? I don't need to do that. In fact, maybe even a waste of time to do that. But I think if you are a good student of mine, if you really care about learning from me, you will really appreciate those lectures. They contain my kind of, expertise condensed about differential equations, everything I know, right? I will try to transmit some of that to you in those lectures. This is part of one lecture because I'm gonna only cover the syllabus, so you have it. But I would like to give you a proper kind of introductory lecture. Particularly, I want to give you a tour of the differential equations that I like and love, right? And also a tour of the differential equations that you would have to like and love in this class, right? So that will happen in lecture 1 once I recorded it. Today is only the part about the syllabus and the Canvas tour. Then I have lecture 2 on exponential and logistic growth. There is also a laboratory on exponential and logistic growth. Particularly, that's very nice because we condense everything about like units 2 and 3, right? Unit 1, 2, and 3 is encapsulated entirely in this lecture. Unit 4 is encapsulated in this lecture, and Unit 5 and 4 is also in that lecture. Unit 4 is also in that lecture, but that's kind of different because that's more going on to non-linearity, right? So that might be actually a relatively short lecture. It's essentially considering the nonlinear pendulum and tell you how we use phase space to actually understand the nonlinear pendulum. And then we have systems of linear ordinary differential equations. Man, you're gonna suffer in there. You need to learn some linear algebra to do that stuff. And I don't know what I'm actually going to be doing there. I haven't decided how I'm going to approach this lecture. I might actually do it entirely by computer. I have no idea how I will approach this lecture yet. What happens in our college is that our linear algebra class is a 200 level course. So people get to differential equations without linear algebra. But this entire unit is the most important unit of the course and it's based on linear algebra. So what is happening is like you get a one lecture introduction to linear algebra and then, off you go, right? The other thing is that these linear systems can be solved and programmed in seconds in a computer. So I haven't decided yet how I'm going to approach this. Now, nonlinear systems always in the computer, so that one is easier, and in fact you have a project about that. And finally, there is series solutions. And in fact, most of my work, recent work, has been on series summation methods. So I am gladly to give you a proper series, a proper introduction to that as well. Let's go. Laboratory sessions. There is lab number 1 is 2 labs, which is creating a computational infrastructure for this class. So you will have to get a set of solvers, right? Either in the Wolfram language or in Python, although, if you want to do it in any other programming language, you can, right? That you can use, particularly if you can run them on your own device, right? That's what I appreciate. That you might have no internet connection, right? Yet you would still be able to solve on your device. If you can power your device, right, you still will be able to solve differential equations. And those 2 labs there, which is only 1 lab, will tell you how to do it. And there are 2 types of solvers, symbolic solvers. The output is going to be a formula. There is another type of solvers, numerical solvers, which will give you your solution sampled on a set of discrete points and maybe interpolate in between. Numerical solvers, the output will be numbers, right? A set of numbers. Or an interpolating function that, interpolates between those numbers. Here I'm adding these 2 labs. In fact, there is another lab, so this needs to be updated because I have put a lab on the logistic equation. So yeah, I don't know exactly. This I played it by ear. So if I think that 5 labs are too much, maybe for a 7-week course is too much, then maybe I keep it to 3 or 4, right? And maybe these ones, since you have the project. I think having these 3 or 4 labs is enough for you to get, the basics. And then autonomously, you will have to work on your own. There are also projects, and I will show you some projects very shortly. The projects listed here are chaos theory and the end pendulum. That is available. Chaos and delay differential equations is available. Dynamics of attractors is also available. And I have added here, built a 3D gravity simulator using JavaScript and HTML. These projects are developed, so you will find some materials. This project is less developed. So if you like to work on your own, do your own thing, this one is your best bet, and I will show you examples of this eventually. Let's continue. Now there is a notebook grade, and again the notebook will be evaluated twice, once at midterm, once at end of term, and here is the rubric. Neat and tidy, legible, and presents well. You can have a 1-page notebook and satisfy that, right? So at least you get 25%. Right, contains 3 fully solved problems from every subunit in the problem set. Right, that's number 2 here. The notebook contains 3 fully solved problems from every subunit in the problem set. That I'm gonna check, right? I'm gonna go in my head, unit 5, find in your notebook unit 5. Maybe your notebook is messy, right? So if it's messy, you fail question 1. You know how I tell if it's easy to find, is it easy to find unit 5? Or do I have to go there? Ooh, right, and then will be half unit 5 here and half unit 5 there and stuff like that. Then you fail question 1, item 1. Clear notes from my master classes. They should be on your notebook. Steady, sincere effort by the student, right, to document their progress. It's incomplete sentence. So there are 4 items in the rubric. So steady means from beginning to end, non-stop. Sincere means you didn't went to ChatGPT at the end of the semester and did this and a few pages and then chuck it into, right? Yes, then I'm gonna catch you and you lose that 25%, and then yeah, maybe you get that 75. People are doing what they are doing. They are taking the transcript for my recording and chuck it into ChatGPT for a summary and then put it into the notebook. There are tells, right? So I'm gonna discount it from your grade. If I feel this is the case, this bit, you will have to deny it. You will have, you will have to lie to me. You will have to say, I didn't do that, right? And then, it's plausible deniability. But if I feel that, you did that, that I went through the effort of giving my best in a set of lectures for you to take the transcript and paste it into ChatGPT to pretend that you watch them. If I feel that reading your thing, I'm gonna let you know and take the credit. Then you will have to say I didn't do that. So let's play that game. And the thing, this seems that I'm like not polite to you or that I don't believe in you. I do believe in you. I do believe in most of you. I also know for statistically, right, that there is gonna be always 5 or 3 or 2, that they are kind of like focused on, going through the hoop as quickly, as efficient, with the least effort possible. And I have to, I have to preserve accreditation. I have to preserve academic integrity in my classes. So I'm gonna do that no matter what, right? So you are gonna need to be legit. If you are legit, right, there is not gonna be a problem. It's an easy class to pass, right? Those learning outcomes, official learning outcomes, are super easy to achieve, right? Complete the labs, essentially you are telling me you achieved it. If you complete the labs, then the homework is trivial. You don't need even to paste into ChatGPT. You can do your own coding and get all those homework questions quickly. Pim, 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 pim. Right. And that is allowed. What is not allowed is for you to take a screenshot of the homework question and to paste it into ChatGPT and then, put in the correct answer in the homework. That is not allowed. But you will do that, and then you will have to do a lab in a notebook and a project. In the project, it's very easy to tell who knows and who doesn't. It's clear. It's it's self-evident. So who worked seriously, who didn't, right? It's self-evident. Project guidelines will be given in detail, full detail, in Canvas. 25% is the homework. Remember, the homework, in principle, you can indeed screenshot it, put it in ChatGPT. It's gonna answer your problem. Probably for many problems, it's gonna work. For some others, it's not gonna work. But in principle, right, the homework is only 25%. Laboratories, 4, 3, however many there will be, 25%. Notebook, 10%. Yes. Project, 30%. And then there is an end of term oral examination. You have to record yourself and advocate for your grade. Let me be clear about this. One of the human traits I value the most is people who are honest, right? In society, I think that we take, to function, we need people to be honest, at least to some extent, right? And that honesty, that sincerity in your work is gonna pay out, right? And in my case, really appreciate my students that show me through their work, right? This is unmistakably, right, honest, serious work. Might not be perfect, might not be, those students have always my grade. Then there are students who strategize very much. I appreciate you too, but it's not the same for me. And then be smart, right? The credit, getting credit, college credit means nothing. The skills are what is important. The skill is what gives value to this. Otherwise, you're wasting your time, right? If you're gonna just like go through these hoops very quickly with some technology, maximize that number in there, it's a waste of time. It's a massive waste of time. It's not worth the effort, right? You don't get anything out of that. If you engage into this content genuinely, this is gonna be one of the most rewarding experiences in your academic life. This course has been consistently being highly rated by students at Monco. 4.8, 4.9, 4.7, right? It's a course I know how to teach. It works very well. The project is something that the students love to work, and it gives the students such an experience, right? It would be foolish of you not to engage, but it's up to you. It's perhaps it's possible to make it without engaging. Yeah, in fact, there is this professor credit, right? Particularly that honesty, that sincere hard work, for me counts a lot. It is the key to a lot of our successes in life come probably from just perseverance and hard work. You don't need to be brilliant, right? You can just like do what you gotta do as well, as much as to the best of your ability. And that typically is enough to succeed if you're lucky, right? So, I reward serious work. I reward originality and creativity and curiosity, right? So if you are curious and you have, gone to your project and do something slightly different, gone down a rabbit hole, maybe it didn't work out, stuff like that. Maybe you wasted a lot of time going down the rabbit hole. Still, I'm gonna notice, wow, he took that detour and got lost, but maybe he learned his lesson, so I'm gonna help him, right? And I use that to kind of level. Typically, it's a course that is easy to pass because the learning outcomes are very easily attainable. And yes, it's that solve, right? So if you understand this solve value, then you are done. Now I'm gonna stop this briefly. You won't notice, but I'm gonna stop and get my canvas, and I give you a tour of the canvas. So here is how it looks like, the canvas. This is probably something pretty similar to what you are gonna be seeing. Let's see if I can, it's kind of complicated. Yeah, something like that maybe. Well, let's look at it. Let's see if I can somehow. This is like so complicated, using these machines. Oof. Well, so you can see that there is some kind of like announcements in there. So here is my original announcement. And there is also a bunch of stuff in here, but also a bunch of stuff in this other side here next to me. So this contains the homepage, announcements page, syllabus, institutional syllabus, modules, and discussions, and as well as Zoom link. And here the homepage is just your modules page plus the announcements. So you can see here the announcements. If you click in there, you will be taken to that announcements. To those announcements. You have a set of lectures. This will be, the credits for the course. You can click in there and see who did what. Collapse all. The laboratories, you already have essentially four laboratories. The two creating a computationally structure with a bunch of videos and my recordings regarding this stuff, just teaching you how to do different stuff. The recordings are a bit old, I'm thinking about redoing them, but I think they are good enough to guide you through. They are a couple of hours long. Let me know if you have any problem accessing those. And if we go back, here is the notebook submissions page. You have two submissions, notebook 1 and notebook 2. I don't think they have deadlines still. This is midterm, this is end of term. I will put them. But if you click there, This needs to be 3 problems, not 2 problems. So, there are some things. Let's click in this one. Let's see. Oh, dismiss. This should be a notebook from one of my favorite students ever, Flynn Casey. She was amazing student, really love her. She got this amazing notebook. It's coming up, I think. Oh yeah. So that's how a notebook looks. I don't know if you can see the number of pages, 70 pages, and it has like examples from every unit. That's how it looks like, a good notebook, right? They are like that. They are always like that, right? They are always clear, typically, always full of pages. The solutions are full. So as you can see there, every single step in the solution is actually being done, right? So you can actually, get that notebook, get also that notebook as a learning material if you want. It's almost like a textbook, right? And you can use it for your own benefit if you want, but also it's the paradigm of how a notebook should be to get my full credit. Next, what else? We want to go back and I continue giving you the tour. So that's the notebook, the projects. Let's see. So I already put some projects in there. Here is the submission page, and there are 3 in there. Have a look. Let's see what we have in here. Okay, so in this project, right, what you have to do is to go to this web page. And you have to build, essentially reproduce some of these visualizations. Here is the Langford attractor. Yeah, there it is. In these ones, I like to put myself close to the paywall. Here, yes. So you have the attractor, and I can point to this. Oh yeah, I like doing this kind of things. But this is a beautiful attractor. Let me tell you what is going on there, if you allow me. So you can see here in there. Let me move myself. Although here, right here, this is the system of differential equations, right? You have dx dt, dy dt, dc dt, and then some, right? For those parameters, if you have x of t, the solution of this one, y of t, the solution of this one, and c of t, the solution of the third one, you can put a point in the space, x of t, y of t, c of t, and as a function of t, that point will move around. So that's what you would have to do in this project. Simulate, reproduce some of these graphs. There are some very beautiful ones. Let me show you my favorite. My favorite is the doggy attractor. I think it's this one, or it might be this one, Thomas 3JS. Yeah? But this doesn't move. I want one that moves. This one moves. Yeah, let's place myself here in the middle because I kind of like that. So this one is kind of one that if I kind of rotate it, kind of looks like a dog. A kind of dog will appear here eventually. Let's see if I can get the doggy. Oh, it's kind of proving difficult. More difficult than... Oh, that must be the no... Oh, there it is. Do you see the doggy? Here is the doggy differential equation. Yes, rotating doggy. So you can recreate the rotating doggy. Up there you have those differential equations. So you can really solve those. And again, you can use ND solve value, check this in with some values of the parameters. And it's not that it's gonna come out like this, but with a little bit of work, you are gonna be able to do that. I might have somewhere some code that I will be posting the project page. Another thing that I wanted to show you is here in the syllabus, right? In the syllabus, I have put a tentative pace because you can see that my homework hasn't got any deadlines. You decide, at your own pace how to solve it. The labs have deadlines, the notebook has deadlines, and the project has a deadline at the end of term. But because I don't rely too much of deadlines, here you have a list of, where you should be at every week. And it's been now written up until the midterm, right? And to complete, so Start work on the project, 3 weeks for your project, you know. You should start as soon as you can. You should start probably. After doing lab 1, you should already be working because it's pretty difficult. Probably, it might be easy. Let's see. Let's see if I can do this. Maybe I can show you how a code for an attractor looks like. I don't know that I have it. That I have it with me, I think. Let's see if I go here and I go here and I put file. Yeah, so I have here my files. So I have the Lorentz attractor and some bunch. So let me see this one. New chain. So you can see a bunch of particles. They start at some location and then they started moving and they are kind of forming some kind of shape. But this doesn't have very many particles, right? So it's kind of like they're, you know, rotating. This doesn't look very good to me. But yes, there is a code, right, that I'm loading into my browser. It's going to my file system. It's loading this code and it's visualizing this attractor. So that's one of the projects. The other project is on what? Let me find it. The other projects are on chaos and delay differential equations, chaos theory, and then pendulum. And there is another one. The other one, I'm gonna do it. Let's see if you can write a 3D version of the gravity simulator. Gravity simulator. So here is the gravity simulator. My cat is complaining. So yeah, so here is, but it's not very, it's better like just to do a bunch of like things like that and then put a planet in there or a star, some bunch of stars. Oh, maximum planets. So I'm gonna build a super mega planet there where everything is gonna fall onto it. And you can do stuff like that. So maybe you can do a 3D version of this. This is 2D. You can do a 3D one. And that would be a good project to add to the list of projects. The projects are hugely successful. The students love the projects. And I'm very happy that you know, that I have given this opportunity to the students. So it's absolutely great. Now here you have your homework. So here is how it looks like. You have a set of lectures there. You don't need to see those lectures, although maybe you won't. You have here a set of learning objectives, a set of readings, and a set of videos, and a set of problems. I click on the set of problems, and it's coming here, and you can see it in there. Let's see. Yeah. Before I kill my cat, I may kill my cat. Let's see if we can see my cat. Why are you so annoying? Look. I'm working on my classes. You know, recordings are hard to do with a cat like you. You must absolutely let me record my classes. Say hi. Mm. Yeah, having a cat is such an annoying animal. I'm working, let me be. So essentially you have the bunch of problems in there. Now the deal is 3 on the notebook. The rest of you are on your own. You do whatever you want. You can use this solve value. You can do it in the computer. However you want to do it, you can do it. I'm okay with it. More things on the modules. Yes, the projects, the homeworks, it's always the same, right? So you always will have a bunch of lectures. You can choose whether to watch those or not. Then reading, viewing, and problems. Reading, viewing, problems. Reading, viewing, problems. Reading, viewing, problems. 3 of every subunit in the notebook. So I'm gonna leave you with that. I have commencement today, one of my favorite days of the year. So I'm very pleased of being with you. I hope you enjoyed the recording. I will be posting some more other stuff shortly. So I keep you posted. Thank you so much for watching. Ciao.